Hello everyone, this is Alex and welcome to Terraonion FPGA Direct. Back in October 2016, we founded Terraonion SL, an engineering company focused on retro gaming, founded by retro gaming fans to deliver innovative retro gaming products. To achieve this, we have a skilled team composed of hardware and software engineers, experts in classic systems, emulation, and embedded systems. We develop all of the different parts of our products, and our skill set is composed of schematics design, PCB layout design, FPGA coding in VHDL and Verilog, MCU coding in C, desktop application coding in C#, cells design, injection mold design, package design, integral production management, and sourcing of the different parts. Our first project was MegaSD. MegaSD is an FPGA cartridge emulator for the Neo Geo and was released in two different forms, MegaSD AS for the home console and MegaSD MVS for the arcade boards. Our goal with this project was to deliver a cartridge emulator that will emulate all the different types of custom chips present on the Neo Geo game cartridge using FPGAs. It will transfer the ROM data from the microSD card to the internal cartridge rewritable memory, so collectors could keep playing their games while they preserve their original media in the best possible condition. The main object of the project was accuracy and bringing players the same experience they have with the original cartridge. To achieve this, we decided to use flash memory instead of RAM memory. The largest Neo Geo game is 96 MB, compared with the biggest Mega Drive game that is just 8 MB. So, achieving an instant loading method using RAM is not possible at all due to the large amount of data that has to be transferred from the microSD card to the cartridge internal memory. That's why we decided that flash memory was the better choice, because once it's written, the cartridge can be powered and game persists in flash memory. This gives players the same plug-and-play experience as the original cartridge offers, where you just turn on your Neo Geo and the game instantly boots. In the months following the MegaSD release, some users expressed their interest in a MegaSD-like cartridge that will use RAM instead of flash, therefore allowing them fast switching among games. Even the sum of multiple RAM writing times will be bigger than on flash. In the summer of 2017, we started to develop a flash and RAM cartridge, one that will allow to store 4 times the biggest Neo Geo game on flash and 1 time on RAM. That will sum a total of 5 slots of 96 MB each, 1 independent RAM store for fast switching games and 4 independent flash slots for persistent instant-on games storage. We called this product MegaSD Pro, and it will contain a total of 480 MB of memory, which is 5 times the memory amount of the biggest Neo Geo game. The hardware design was so deep that it required a 6 layers circuit board with matched signals layout. In March 2018, the product was ready to market, and after we announced it, we had planned a 3-month window for factory production, opening sales and start shipping the first units to customers about June 2018. What happened from March 2018 to January 2019, when we finally opened MegaSD Pro sales, was something great and forced us to delay MegaSD Pro market release. Just after MegaSD Pro reveal, Rasola, the creator of custom Neo Geo BIOS UniBIOS, contacted us with an idea. Now that you guys have a Neo Geo RAM card, why not make the Neo Geo CD games running on ACE of MVS? We instead loved the idea of playing Samurai Shodown RGP on ACE, and this was something we really wanted. But there was an issue. The MegaSD Pro hardware, as it was designed to work as a regular card, didn't allow that, mainly because of the CDDA audio output and the writing of data to the full Neo Geo CD-RAM area. So the hardware and the software design had to be changed, and the whole MegaSD Pro launch will be delayed. But we thought it was worth it, so we decided to update MegaSD Pro hardware and software design to include all the necessary changes to run Neo Geo CD games. Even with the updated hardware, there were still a few challenges. First, there is no access to any uncompressed or analog audio output from the cartridge. So, in order to play CDDA, we used the AD-PCM-B channel that Neo Geo CD games don't use, and made the FPGA and MCU to trick the Yamaha audio chip into thinking it's playing a long sample from ROM, but actually streaming the CDDA music while compressing it to the AD-PCM in real time. Of course, this creates some limitations, as you aren't playing full quality CDDA audio anymore, and because of the AD-PCM recompression, as there is only one channel, the audio is mixed to mono, but it's still 45 kHz, so it sounds great. Another problem was the Neo Geo CD BIOS. A replacement BIOS had to be coded from scratch, so the games call it to thinking they are calling the original CD BIOS routines, and redirecting the games to call those routines instead. That includes CD file reading, CDDA commands processing, data upload from main RAM to any of the Neo Geo CD-RAM areas, memory card access simulation if users don't have an actual memory card plugged onto ACE or MVS, and some other things. We also wanted to support the original loading screens each Neo Geo CD game contained, so there was a lot of work to do, and here is where we could count on Rasola to use his knowledge of Neo Geo BIOS and Motorola 68K coding to help us with the creating an accurate replacement of the Neo Geo CD BIOS routines to use with MegaSD Pro. All those changes were generic, that will make many games work, but then there was another issue. Neo Geo CD memory map is slightly different than the MVS and ACE memory map. Neo Geo CD has a continuous 1 MB area for RAM, mapped at 100,000 H, while on MVS ACE there is only 64K there, and the banks area that we can read and write with the new hardware added to the MegaSD Pro is not located at the same address. It's located as at 200,000 H instead of 100,000 H. So for many games this needs to be remapped while loading from CD when the game uses that data. This forced us to create a special Neo file for each game that contains the remapping of the addresses specific for each game, and this was a big task that required a huge amount of time. Also, the addresses in the Neo Geo CD that correspond to the ROM addresses in MVS ACE are RAM and thus readable on Neo Geo CD, but there are no signals in MVS ACE cartridge connector to allow writing there, so the games that are writing there, usually to build the CD file loading list, needed that block remapped to RAM, where it can be read and writing. All of this work ended up causing a 7-month delay of the MegaSD Pro launch. Great news is that from today there is a new firmware update available for free to all MegaSD Pro users that enables playing Neo Geo CD games on Neo Geo ACE and MVS. On top of this, we have also added all possible with MegaSD hardware new software functions MegaSD Pro has into regular MegaSD, such as cheats and in-game menu, because our goal is always to deliver as much as possible to all of products. In addition to the Neo Geo CD firmware, the first set of custom Neo Geo CD Neo files are also available at our downloads section. Those Neo files don't contain any copyrighted material and will require a BenQ image of the original Neo Geo CD game to be placed on the root of the microSD card that NeoSD Plus users can create from their original Neo Geo CD discs. This first set of Neo files contain the most challenging to adapt games such as Samurai Shodown RPG, Neo 12 Masters, Thin Trick, Iron Clan, and much more. I hope you guys enjoy this awesome milestone, playing Neo Geo CD games on ACE and MVS with loading time reduced to just a few seconds. It's an amazing user experience. Lastly, we would like to thank Rasula for all the amazing work and feedback he has provided us, as most of the work on Neo Geo CD games Neo files has been done by him, and to recommend everyone owning a Neo Geo AES or MVS to install an Unibios chip. If you still don't have it, it's an awesome addition to your Neo Geo. Both regular NeoSD and NeoSD Pro in the two different variants, AES for the home console and MVS for the arcade boards, are available at our shop on the link below. Unibios, Neo Geo Custom BIOS, can be acquired on the link below. I would also like to remind everyone that all of our different NeoSD and NeoSD Pro versions are fully compatible with the great Unibios. Okay, so after all the Neo Geo CD excitement, it's time to talk about our second project, Super SD System 3, the PC Engine all-in-one optical disc emulator. But first, let's have a recap about what the PC Engine is. PC Engine is a console released to the Japanese market in 1987. There was an overseas release in USA and Europe 2 years after under the name of TurboGrafx 16, with a much more reduced catalog. So let's focus on the original and more extensive Japanese catalog. The PC Engine catalog is composed of 5 different media types, each requiring different hardware or add-ons. Those are HuCard, the regular cartridge games in a card format. Those can be played on any of the different PC Engine's based consoles. CD-ROM 2. Those games were released on CD format and required one of the different CD drive add-ons with at least 64K of RAM memory among a system card in HuCard format, containing the required BIOS to be run. Super CD-ROM 2, same CD format at CD-ROM 2 games, but requiring 192K of RAM memory instead of the base 64K. This additional RAM can be acquired by using a system card or contained on the later CD-ROM drive models. Arcade CD-ROM 2. Like the two previous CD formats, the required RAM memory has been raised to 2 MB, and the only way to play those games is by acquiring the expensive arcade card. SuperGrafx HuCard, same format as regular HuCards, but requires an upgraded console model called SuperGrafx. In addition, the PC Engine lacks RGB output, so we decided to build a device that will support all those different game formats and also contain a built-in RGB output. Super SD System 3 plugs into the expansion port of the PC Engine, and the rest of the different models that have an expansion port allowing to play those PC Engine media formats from the internal SD card port while having a built-in RGB output, and without requiring any additional hardware such as the different CD-ROM drives or system cards. Only the 7 released SuperGrafx HuCard games require an actual SuperGrafx console in order to be played. Super SD System 3 emulates all the hardware inside Next CD-ROM drive add-ons using a mix of FPGA and MCU code. The FPGA does the interface to the extra RAM inside the CD-ROM drive, and also for the RAM that is present in the system card and the arcade card. At the same time, it implements the SCSI interface of the original CD controller and requests the MCU to read and set back sector data, while it buffers so the PC Engine can read it. The FPGA also forwards the ADPCM reads and writes those to the MCU. The MCU handles the sector request, reading the data from a bin or ISO CD image file and send it back. At the same time, it also performs ADPCM audio decoding and mixes it with the CDDA audio from the CD image file that is buffered inside the FPGA and sent it to the DAC for mixing the PC Engine audio. As a nice addition, Super SD System 3 allows for independent backup RAM saving into the SD card, allowing infinite save slots, and the ability to backup your original HuCard and SuperGrafx HuCard games to the microSD card. Over the last several months, we have been working to improve the quality of the audio and RGB video output signals with the help of some skilled technicians. We would like to say thanks to Voltaire for sharing with us his RGB output design Firebrand X, for sharing with us his audio bypass design, and Mobius Strip Tech for validating our new board revision. Thanks, guys. Your know-how have made Super SD System 3 video and audio output better. Okay, after all those wonderful products, most of you were wondering what's next. And what's next is the hardest project we have ever worked on. Just after Super SD System 3 market release, people started asking us to develop a similar product for MegaSD. The main issue with Sega CD is that it's more a console itself rather than a CD-ROM drive add-on like the PC Engine CD-ROM drives are. MegaSD motherboard contains a Motorola 68K processor, a custom VDP graphics processor that most MegaSD games use for 3D-like rotations, along with audio hardware and CD-ROM drive controller chips. So even if it's a CD add-on, it's more like a separated console because it has its own processor, graphics processor, and CD-ROM drive controller. Everything is integrated on a single printed circuit board, so the only way to make a similar solder's plug-and-play solution like the Super SD System 3 was to make a complete FPGA MegaSD console, one that all contains all the original MegaSD hardware replicated into a FPGA and works with all the existing Mega Drive and Genesis consoles. So we did. I am happy to introduce you MegaSD, a FPGA MegaSD in a Mega Drive cartridge form. The MegaSD project started back in October 2016, just after NewSD was introduced to the market, and it took 2.5 years to be completed. MegaSD was our hardest project to develop because it's not just an optical disc emulator as some people might think. The Sega CD is almost a complete console, with its own CPU faster than the Mega Drive 1, a sound chip and a GPU capable of drawing scaled and rotated graphics, so it required a lot of effort to accurately simulate all that hardware into a single cartridge. It also contains a lot of RAM, in multiple buses that can be accessed simultaneously. That's why you will notice several RAM chips in the cartridge, instead of using a large one. MegaSD's FPGA contains a Motorola 68K software core running at 12.5 MHz. This core is accurate and able to run all games as a real 68K. It supports all features needed by the Sega CD, like auto-vectored interrupt ACK cycles, two-wire bus arbitration, and others. It's connected to 8 MB of SRAM, with only 512 KB being used for Sega CD program RAM and 256 KB of fast RAM used as word RAM. Unlike the Sega CD, there is only a RAM chip used for word RAM, so when the main 68K that is present on the Mega Drive and the sub 68K that is present on the Mega CD both access it, it's multiplexed. But as this RAM is 10 times faster than the real Sega CD RAM, there are no extra wait states required. Furthermore, accesses had to be slowed down to simulate the long access time in the Sega CD that causes Mega CD processor VDP to lag by 1 word when doing DMA transfers from word RAM. The word RAM bank switching is also implemented on the FPGA, with all its knowing quirks and verified to behave the same than the real hardware. Then we have the GPU. It's capable of rendering rotated and scaled telemaps to the word RAM in a format compatible with Mega Drive's VDP, so the main 68K processor just needs to transfer them to the Mega CD VDP as is to display. The most complex part of the GPU is the access arbitration, because it's possible to have the sub 68K, DMA and GPU all accessing the same RAM at the same time. Also, the GPU can do read-modified write accesses to the word RAM in order to skip drawing on already drawn pixels. This all creates a complex system of priority arbitration that must be properly handled. On the sound side, the audio chip is not too difficult to simulate. It's an 8-channel, 8-bit signed sampler player that plays the audio from its own dedicated RAM. It has the added difficulty that the 68K can write and DMA data while it's playing, so it's necessary to multiplex the accesses to the RAM. And then, of course, there is the CD-ROM interface. It can be divided in two parts: the CD controller, CDC, and the CD drive, CDD. The CDC is a standard CD controller from Sanyo that receives the raw CD sector data and performs decoding and error correction. It contains 16 kilobytes of RAM, where it can store up to 6 raw sectors, so it's able to receive more sectors while the sub 68K is reading the previously received ones. The tricky part on the CD-ROM is having data being sent at the proper speed, as some games are designed to keep the CD-ROM streaming data continuously, and sending data too fast will cause the sector buffer to warp around before the 68K has read the data. That's also why an accurate 68K is needed, so they properly sync with the read speed. All the previously parts are implemented inside the FPGA, in synthesized hardware, so everything runs in parallel like in the real Sega CD, no software emulation. And finally, the CDD is the serial drive controller and is implemented on the MegaSD's MCU element. The FPGA passes the CDD command as is, as in the real Sega CD, where they are handled by a separated 4-bit MCU to the CDD that processes them and sends the status back. Commands include talk, decoding, and retrieving start playing at a given sector, pause, playing, seek. These commands are handled by a state machine in the MCU. When a play command is requested, the MCU will start sending sector data at the proper speed to the FPGA to be stored in the CDC sector buffer. Having everything run in sync was a very hard task. The day that Sonic CD voted in the intro screen, it was an amazing day. Once we had the first prototypes running, we had to choose to make a device that would plug into Mega Drive's expansion port like the original Mega CD does, or to pack it into a cartridge form. Both solutions have pros and cons. The pros about the cartridge port are that regular Master System and Mega Drive games can be loaded and played. Master System games can be played from it, while it's not possible from the expansion port. Also, there is a ROM size limit on the expansion port that won't allow ROMs bigger than 256 kilobytes to be launched from it. This applies to both 32X and Mega Drive game ROMs. Also, as the cartridge connector has 2 pins to input stereo analog audio to the Mega Drive mixing circuit, we can use them for the sound chip and CDDA audio. This audio is output at CD quality, 44 kHz stereo, 16-byte, using a high-quality audio amp circuit designed by Firebrand X, who also helped us to improve the Super SD System 3 audio output. If you still don't know about Firebrand X, have a look at his Twitter. He has done amazing work to improve Mega Drive audio with his own crystal clear audio modification board. The cons of the cartridge port are that the only 6 Sega CD 32X games can be run from it, because when the cartridge is plugged through the 32X, accesses to the Mega Drive memory addresses where the Sega CD registers are stored is blocked by the 32X circuitry, and so it's not possible to communicate with the Sega CD through the 32X. Good news is that we designed Mega CD to be able to be plugged into the expansion port as well. This will just require a passive adapter that we are considering to produce in the near future if there is no interest in those 6 Sega CD 32X games. I would also like to mention that Mega CD is compatible with standard no CD 32X games if the user has the 32X hardware plugged into the Mega Drive. CD games needed to be removed to be played because of the previously mentioned issues. MegaSD has been tested on different official Mega Drive models, and as part of its design, it requires the audio input signals to be present in the cartridge port, just like the original Mega Drive and Mega Drive DOS designs have. On the Sega Nomad, Sega decided to not route those 2 pins from the cartridge to the audio missing circuit. So in order to get CD audio sound on Sega Nomad, the same mode that is required to get Master System FM sound on the Nomad has to be performed. It just constrains to wiring 2 pins with 2 wires. In addition to MegaSD being able to play Master System, Mega Drive, Mega CD and 32X games, we have introduced a 5th type of game. We call these Mega Drive Plus games. This is similar to NSU1 games on the SNES. Those are Mega Drive games modified to use MegaSD's CD audio hardware. Here is an example. On-Room Mega Drive modified to play On-Room 2 arcade audio tracks.
Get ready.
Get out into the night, it would be oh so right. I gotta do that.
MegaSD production has already started, and it will be shipped with a black transparent smoke cell with the same design as this prototype cell and with the same look and quality as the NewSD Pro cells. It will be packaged into a premium box package similar to the Super SD System 3 box, and it will come with a manual and sticker applet. Finally, I would like to say thanks to Alien PDX for designing the pixel art on our products, user interface, and to all our customers and partners that have made all these amazing products possible: NewSD, Super SD System 3, NewSD Pro, and MegaSD. Amazing times for retro gaming, and remember that the best is still coming. See you all in the next Terraonion FPGA Direct video. Enjoy life and enjoy retro gaming.